Hey guys, welcome back to lecture 31. And in this lecture, we will be covering summations, right? Very important concept, but it is easy to understand. There are a few concepts in summations that are a bit tricky, but we will make sure to cover everything in detail, right? So, what is a summation? Summation is a way to add terms of a sequence, right? Instead of writing it like a1 plus a2 plus a3 plus an, we represent it with this symbol. So let me just give you guys a quick overview, right? Think about in equations where you have to add a lot of numbers, or in algorithms where you're supposed to write a lot of numbers and you have to represent it, right? It doesn't make sense to represent it in this way, right? You can't just keep on showing a plus sign and making a very huge algorithm and writing it on a sheet of paper or your computer, right? You need a better way for the representation of showing something. And that is exactly where this summation comes in, right? So what it means is, it basically means the same thing as what we have over here, but in a very interesting way, right? So instead of you having to write all these pluses, we just use this representation. So anyone reading it can get a clear understanding of what is happening, right? You don't have to write the entire statement. So let's try to understand what this means. Over here, this symbol basically means the sum, right? This sigma symbol is what we call the sum. This I value that you see at the bottom is what is going to be the start of the summation, right? That we are starting at the value 1, I should say, right? The upper value, the one above the sigma, is going to be where we end. N could be any value. It could be, let's say, 5, 6, 7, any sort of a value, right? And this is going to be the expression that we keep on adding. So the meaning of this is that I start with A1, I keep on adding A2, A3, A4, I keep going until AN, right? So if you look at this carefully, right, I started at A1, this I equal 1 represents my lower limit, this N represents my upper limit. And if you look at it carefully, right, I stopped at AN at the end. So I added all the values from A1 to AN, right? So over here, I've given the pretty much the description of each value over here. I is the index. I equal 1 means start here, lower limit. Now, I doesn't necessarily have to be 1, right? It could be anything. So just be clear that it doesn't have to be 1. Now, n is equal to stop here, which is going to be the upper limit, right? And then ai is simply going to be the actual value that we keep on adding, right? So I've given two examples in this case as well. One example is, if you consider this one, right? Basically, the term is I. You start at I equal 1 and you keep going until I equal 5, right? So if you look at this carefully, right, I have to add the term I and I keep on adding it. So I start with 1, 2, 3, 4, 5, right? Giving me the total of 15. So this basically means I'm adding all the numbers, start with 1, 2, 3, 4, 5, right? If you look at the second one, now inside this, the expression is I squared. So what I have to do is I start with 1, keep going up till 4, and I'll keep on replacing this I value with the values 1, 2, 3, 4, right? So if you look at this, first I replaced I with 1 square, second I did it with 2 square, 3 square, 4 square, right? I hope that basically makes sense. Okay, so the entire point is that you don't want to have this huge representation of something when you could have like a smaller expression to represent the adding up, right? And that's exactly where the summation symbol comes in. Okay, I've given this another like sort of an example of relation to coding. So if you kind of relate to coding, right, this summation is pretty much like a for loop, right? You basically start by declaring a variable sum equals 0. You start at whatever the I value is. It could be 1, it could be 0, it could be anything else. And then you keep on going of the for loop until the end n, and you keep on adding the value ai to the sum, right? Pretty simple sort of a for loop situation over here. And the lower limit is pretty much loop start, the upper limit is the end, and expression is what you keep on adding, right? So very simple to understand. It's just a simple formula with I equal 1, the one beneath the sigma symbol being the lower limit, the one being above the upper limit, and this is the entire expression. The expression could be I, it could be I squared, it could be a constant multiplied by I squared, it could be multiple variations of it. We'll take a look at a few examples pretty soon. But now let's try to understand the properties of summations. Okay, guys. Now let's try to understand some of the properties of summations. These properties are very simple to understand, so they will start making sense pretty quick, right? The first property is take out all the constants, right? This is very simple to understand. So let's say if you have the summation, and in that you see there's some expression AI. So let's say AI is the expression, right? Expression could be something like any sort of a sequence expression that has been given to you, right? AI over here is to represent any sequence. C over here represents a constant value. So let's say you've been given a summation where you have this AI expression inside it, and we are multiplying it by a constant C. Then what you can simply do is you can simply just take out that constant C outside, right? Very simple. So second one is split the sums, right? Now again, this is very simple to understand. If you have a summation where you're adding basically two different sequences. So for example, this AI could be an expression where A1 is, let's say 1, A2 is some certain value. Maybe in this expression or this sequence, you're multiplying each value by 2. And maybe in BI, you're multiplying each value by 3, right? What I mean by that is that these could be two different sequences, but we don't really care about that. Point is that if there's a summation and you're trying to add these two sequences together, what you can do is you can also possibly separate them into two different sequences as well, which is you can do the summation of the AI individually. You can add it to the summation of BI, right? Okay. Next one is change the index. Now, this is again very simple to understand, but it might seem a bit tricky over here. All you've done is I changed the index and the element of representing the lower limit to j. So if you look at this carefully, right, I changed it to j, and then I changed the value of j equals 0. But after changing the value of to 0, I also need to make some other changes, right? So first of all, one change I made is now j is 0. I need to go only up till n minus 1 because I've taken a step back, right? Secondly, if you look at this carefully, earlier I had ai, but in this case, I had to add a j plus 1 to the element in this case, right? It is pretty much the same thing. It's just that I've changed the index. That's pretty much all. Last one is split the range, right? So this again is very simple to understand. Think about this, right? Summation at the end of the day is just you start at a certain place, you keep on adding all the values until a certain point, right? But you can split anywhere you want. You can split it in the half, and then you can add a certain half of whatever you want and the other half, and then you can add them together, right? Addition is pretty much associative, so it doesn't matter how you add things up, it is going to result in the same thing. So over here, if you look at this carefully, right, in this property, what I've done is if you have some summation of AI starting at I equal 1 going up till n, what you can do is you can split it, right? So if you look at this, we split up the summation, we start from I, but we only go up till some value k. This k could be anything, right? It could be somewhere in the middle, somewhere, let's say the third or the fourth value of the sequence, right? Next thing we do is, for the next one, we start at k plus 1 and we go up till the very end. So it's just pretty much that I've split the summation addition in two separate halves, right? Now, these properties might not make sense, like what's the purpose of them, but I've given a small example over here which uses the pull-out constants and the split sums situation over here. But the more you practice, the more you will understand how to use these properties. Once again, they're pretty much meant to make things easier and simpler for you guys, right? So once again, in constants, what you do is you see a summation, there's an expression and there's a constant value multiplied to it. You can just take out that constant and do the summation of simply the expression you have. Split sums, what you have is if you have two different sequences being added together inside a summation, you can split them out outside, right? Change index is just, again, a very tricky situation. All we did is change the index, but we need to make sure that whatever the resulting summation is, we are not messing things around, right? We're not messing with the index that was earlier there. last one, split the range. All we did is we had one situation where we go from I to n. We just split it. We are first going in this first summation from I to certain value k, and then from the k plus 1 to the end of the summation, right? Which is kind of like, let's say I had 1 plus 2 plus 3 plus 4 plus 5. All it did is, let's say it added 1 plus 2 first, which gave 3. 3, 4, 5 it added together by itself. So let's say it gives 7 plus 5, which is 13. 7 plus 5, which is 12. And this they finally add together, which gives us 15, right? Let's take a look at this example that we have over here. So we have a summation going from I equal 1 to I equal 5, right? The situation is you have in the expression 3i plus the constant value 2. Now remember, over here I have two expressions, right? This 2, even though it's a constant, it is kind of still an expression in our case. Secondly, you have this another expression 3i. So the first thing, if you look at it, we did is we split it into two things using the split sums property. So we get 3i plus the summation of 2. Another thing, I did two steps in the same pretty much step, I should say. So I should have added multiple steps. But the point is, in the first step, I used the split sums property. In the next step, I used the pull constants property. And I pulled the 3 out of this 3i situation over here, right? Which gives me 3 multiplied by 15 plus 2 multiplied by 5. I'll try to give a quick explanation. Think about this, right? You have this I inside the summation sign. So what you're doing is you're doing 1 plus 2 plus 3 plus 4 plus 5. Summation of 2, summation of a constant basically means that you keep adding this constant until the end of the loop, right? So since I started I equal 1 and 5 and there's a constant value, this basically means 2 plus 2 plus 2 plus 2 plus 2, which basically means 2 multiplied by 5, right? So finally we get 3 multiplied by 15 plus 2 multiplied by 5, giving us 55 as the final answer, right? So very simple properties to understand, but very important to keep in mind, because if you're given, let's say in an exam, you're given a very complicated sort of a summation, it is very important that you know these properties so you can use them and make things easier for you, right? Like if you look at this situation in itself, right, it would be very difficult if you were trying to do this by brute force, by just adding all the values one by one. But knowing these properties kind of made it way easier for us to do, right? Okay. Okay, guys. Now let's try to understand some of the very important formulas. Now, these might seem tricky to understand, but I would say they're very important to remember. So you should just literally, I should say, remember all these formulas by the name and knowing exact the equation for it, right? I would say it's very important. We will cover the proofs of these in the next lecture, but for now, I would say just remember these formulas and maybe solve a few practice problems for each, right? Okay, so let's look at the first one, which is the sum of integers. This is very simple to understand. You have probably come across this equation maybe in your high school or maybe once or twice before as well. So what's happening is, if there's a summation of a simple value I, which is going from the value 1, lower limit 1 to n, then it's simply n plus 1 divided by 2, right? This is just a very basic formula. One of the examples is, let's say if I'm adding the integers from 1 till 100, instead of doing that manually, what I can just do is I can use this formula, right? So I see, okay, we have 100 values, n is 100, n plus 1 would be 101 divided by 2 would give me the entire sum. So it's simply an equation that I can use directly. I don't have to actually sum up all those values myself. Second one is the summation of I square from I to n is basically n plus 1 to n plus 1 divided by 6, right? This is called the sum of squares equation. Once again, this is just a formula. There's not much understanding to it, but we will be covering the proofs in the next lecture. So don't worry for now, right? Okay, I've given the example once again in this case, which is, let's say we are adding the numbers 1, 4, 9, 16, 25, right? If you look at this carefully, this is 1 square, this is 2 square, this is 3 square. So these are all squares, right? That's what the I square represents. Now, since I'm going up till 25, which is the fifth term, n would be 5, n plus 1 would be 6, 2n plus 1 would be 5 multiplied by 2, which is 10, plus 6, plus 1, which would give me 11, right? So 5 multiplied by 6 multiplied by 11 divided by 6, which gives me 55, right? Once again, like this is just again an equation which you can use instead of having to do the sums yourself again and again. Okay, next one, third one, this is a bit more tricky to understand. I should say a bit more difficult to understand. What's happening is, if you have some value r, right? Now this value r could be anything. It could be 1, 2, 3, any number, right? And the power to it is the I. I is basically the expression, like the one that we are looping through the value, right? The equation for that would simply be r to the power of n plus 1. You subtract 1 from it divided by r minus 1, right? Probably a very tricky equation once again, but don't worry, we will cover it in the proofs video, right? Okay. This is called the geometric series. And there's one important point that I would like to make in this video, which is this is only for when r is not equal to 1, right? So we need to make sure that r is not equal to 1. And the reason is very simple. I would like you guys to pause the video and try to figure out what exactly would that be. Okay, so the reason is pretty simple. If r is 1, then I would have 1 minus 1 in the denominator, right? Which would be, which is incorrect. But another thing to notice about that is, if r is 1, then I would have something like I equals 0, 1 to the power of I. If you look at this simply means I keep on adding 1 n plus 1 times. This would give me, okay, keep on adding 1 plus 1 plus 1 until n plus 1 times, right? You can try to pause the video and understand what I'm exactly trying to say. But if r value is 1, then 1 to the power of anything would simply be just 1, right? And since you're doing the summation, you'll keep on adding 1, 1, 1, 1 multiple times, okay? Last one is the power of 2 equation, which is, if you have the summation of 2 to the power of I, it's simply 2 to the power of n plus 1 minus 1, right? One of the examples is 1 plus 2 plus 4 plus 8 plus 16 can simply be written as 2 to the power of 5. Since n over here is 4 in this case, you're starting at 0, right? So this is 0, 1, 2, 3, 4. 2 to the power of 5 minus 1 giving us 31, right? So once again, try to pause the video and understand these formulas. I would say remember them. And in the next lecture, we will be covering all the proofs in detail, right? Next one, for now, we will move on to the double sums. Okay, guys, now this is going to be the final concept, and then I'll give some practice questions on the board. So double sums is pretty much a nested for loop, right? You've seen like one sum at like the point until now, but now if you look at this, we have double summation symbols, right? What this simply means is that it's basically you're summing up inside another summation, right? Pretty much like a for loop. So let's take a look at this example, right? Over here, I have an outer summation. And I have another summation inside it, right? If you try to look at it carefully, right? I go from I equal 1 to 2. Inside that, I have another element j, which goes from 1 to 3. And inside that, I finally have my expressions, right? Which is I plus j. So what is the evaluation criteria? I'll try to explain very simple steps that you should take when it comes to these type of questions, right? This example over here is very basic one. It's just for explanation purposes, but in the practice problem, I'll give you a more tricky question to solve. But one important step that you should keep in mind is that, first of all, start with the inner loop. Right? I'll try to explain what I mean. What's happening is, if you think about this in a situation, right, this is pretty much like a nested for loop. And if you remember in a nested for loop, so if you have, let's say, for I equals 0, I less than 10, I plus plus, And let's say you inside you have another for j equals 0, j less than 5, j plus plus. If you look at this kind of a situation, right, try to trace the for loop down. What's going to happen is first we will enter the for loop. We will start with the value I, and then we will go inside the another for loop. We'll start with the value j, right? So in the first case, the I value would be 0 and the j value would also be 0. But we will keep on staying inside the inner for loop, right? Once the inner for loop ends, then we will come back to the outer for loop. We will add a 1 to this outer I, then go back to this inner for loop again. So if you look at the situation, right, I started with I equal 1 according to this equation. And at I equal 1, you start with 1 plus 1. 1 plus 1 is why? Because the j value is also going to be 1 in the first place. In the second iteration, you see, I equal 1 stays the same, but the value of j changes. In the third one, the value of j changes again, right? Why we only went up till 3? Because j is going up till 3, right? We change the I value again. This is like the outer for loop, and consider this as the inner for loop, just like the situation over there. It's just that the values that I've given 10 and 5, these are just random values, but pretty much try to imagine it as a for loop situation, right? Okay, second one, second you went I equal 2, and then again, over here in this equation, all the I values are 2, but if you look at this, right, the j values keep on changing. So j value keeps 1, 2, and keeps on 3. And then once you have, for the first equation gave us 9, second one 12, we need to add that up together, giving us 21, right? So now this is more trickier to understand. This could be further nested down. You could have 3 summations, something like this, but the point is very clear, right? What you do is you start with the more innermost for loop, and you keep on going and trying to imagine it just like a nested for loop situation, right? Okay, that's pretty much it for this lecture. Now I'll be giving a bunch of practice problems on the board for you guys to solve. Okay guys, I've given 5 questions on the board, so try to pause the video and solve all of these questions. Okay, so I hope you have solved all these questions. Now I'll try to give the solutions one by one. So the first equation, the first question is pretty simple. We already did this in the video, so you can pretty much like go back and see the solution to the question. It was very similar to it, but I'll try to still explain like what exactly you're supposed to do. We just use the properties of summations, right? So first of all, we have 2 sequences in this case. What we can do is we can do the summation separately. That's one. Secondly, we have this constant value 2 as well, right? So we can take it out of the summation as well. So the final answer to this question would be 36. Okay. Second one, compute summation of I from 1 to 50. Now this again is very simple to understand. All you were supposed to do is use the formula n plus 1 divided by 2, right? And this gives you the solution 1275. Third one, once again, I've already given the formula. All you have to do is just put the equation inside the formula and try to solve it. So the answer to this question would be 3280. Once again, I'm not solving the equation because it's just math, and all you're supposed to do is just replace the r and n value with the correct values that have been given in the summation, right? My focus needs to be on the double summation questions 4 and 5, right? These are important to understand. So once again, I'm going to try to explain double summation. This is very important to understand. Now, whenever you come across double summation, I've personally struggled a lot with double summation question whenever I had this type of a question in exams, right? But now I finally like got a hold of it, so I'll try to explain what I do. So the first thing that you need to do is always consider it just like a nested for loop situation, right? So what I would do is, I've been given I equal 1 and it goes to 3, right? Start every single I and take it, assume it as one single step. So let's say I start with I equal 1. At I equal 1, my inner summation would look something like j equal 1 to 1 multiplied by j, right? Solve this entire equation for I equal 1, right? That's what you get. So let's say final value is some value, let's say x, right? Same thing, go I equal 2 again. Okay, so for I equal 2, this would be, we are going from j1 to 2 again, and this time it's 2 to j. So let's say this comes out to be some y. Right? So what the basic idea is that you consider a value I, and you consider the inner summation for it. Replace the I value with whatever the loops for value is, right? And then try to solve the equation. Keep on doing until you have pretty much solved the equation. So I'll have to go until I equal 3. Let's say I get the final value z, and then I'll add these up together, right? So the final solution to this question would be, this x would be 3 plus y would be 6 plus z would be 9, and the equation would look something like this. So summation, you would have for I equal 1, you do one plus 2, and then for 6 you do pretty much 2 1 2 2, and then for the last one you do 3 1 plus 3, which gives you pretty much 9, right? So I hope this pretty much makes sense. I'm pretty much looking at the answers from one of my lecture slides, just for making sure that I'm not writing anything wrong, right? Okay, last one. Now this one is again a very tricky situation. If you look at this, right, I have this outer summation, which is fine. But if you look at this carefully, right, in the inner summation, I have j equal 1, but then instead of some certain constant value like 2, it gives I, right? So this is kind of like a tricky question, and you could have this in the exam. But once again, take very small steps. Solve it for every single I value, right? So I'm going to start with I equal 1. So for I equal 1, you would have pretty much the inner thing would look like j equal 1 to 1. This is what the inner would look like for I equal 1, right? Now you can pretty much solve it for I, right? Since it's j equal 1 to 1, it would simply be 1 in this case. Same thing, you do this for I equal 2. So I equal 2 would be j equal 1 to 2 j. Now in this case, you have to, the summation is going up till 2. So means you'll have to do 1 plus 2 in this case, which would be 1 plus 2. When I is equal to 3, summation would go up till 3 in this case, right? So that would be 1 plus 2 plus 3. So if you look at the final solution, right, it would pretty much be something like this: 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and the total would be almost, the total over here would be 20. Okay, so probably messed up a bit, but I would say try to slow down the video if you're struggling with double summations. But my entire point is very simple. Treat it like a nested for loop, right? Consider every single I value as one step. I1, consider it one step. Do the inner for loop, solve the inner for loop, right? Next step, go to I equal 2, solve the inner for loop. And then add up all those values at the very end. Don't try to do it in one single sentence, every single question. Just try to separate it down into small blocks, right? And that's pretty much it for this lecture. And I'll see you in the next video.